Hi everyone, my name is Billy and welcome to this video. Today we're going to look at some worked examples that are based on the formula that we developed in the video just before this, and that was the formula to find any term in an arithmetic sequence. So let's refresh our memory and write that formula out. The formula was that if we wanted any term Tn, we could take the first term T1 and add on n minus 1 multiplied by the common difference. So let's start and take a look at this first example. And the first example is an arithmetic sequence that is this: 3, 9, 15, 21, 27, and comma, so on. And the question is find T11. You put here find T11. The n value that we're going to use in this problem is 11 because it wants us to find T11. T1 is the first term here, and that's 3. And the common difference is the difference between two successive terms. So let's take 9 minus 3 is 6, and I usually quickly do another one just to make sure. Let's do 27 minus 21. That's also 6, so this number is correct. So now we can substitute these values into this equation here, so that T11 is equal to the first term 3 plus n, which is 11, minus 1, multiplied by the common difference, which is 6. So we'll just need to finish off this calculation. T11 is equal to 3 plus 10 multiplied by 6. T11 is 3 plus 10 multiplied by 6 is 60. Therefore, T11, or the 11th term, is 63. Okay, let's take a look at another example. And in this example, we're given that T10, or the 10th term, is 75. The common difference D is minus 3, and the question says to find the first term T1. So let's write our formula out again. Tn is equal to T1 plus n minus 1d. Now, because we want T1 by itself, what I'm going to do is just a little bit of algebraic manipulation. I'll take this term and put it to this side of the equation so that I get Tn minus n minus 1d is equal to T1. I'm just going to rewrite this more conventionally so that I would write it like this. T1 is equal to Tn minus n minus 1d. So I've got this equation ready to go now. Let's take a look at what information we have. N is 10, and I get that from here. D is negative 3. So I've got these two values. Let's substitute them in. T1 is equal to the 10th term, which is here, 75, minus n is 10, and then I write minus 1 multiplied by d. So multiplied by negative 3. Okay, let's finish this up. T1 is equal to 75 minus 10 minus 1 is 9 multiplied by negative 3. Let me just move to the side here. T1 is equal to 75. Negative 9 multiplied by negative 3 is positive 27. So I can finish this off now, that the first term is 75 plus 27, which is 102. In this next problem, we are given this information, that the first term is equal to 5, the 7th term is equal to 47, and the question asks you to find the common difference. Now again, we will just use the same formula, so let's write it out. Tn is equal to T1 plus n minus 1 multiplied by d. And I want to find d. So the first thing I'm going to do is take this term and shift it to the other side of the equation so that I get Tn minus T1 is equal to n minus 1 multiplied by d. Now I'm going to divide both sides of the equation by n minus 1 so that I can cancel these two terms out, and on the right hand side I'm left with d, and on the left hand side I have Tn minus T1 over n minus 1. So that little bit of algebraic manipulation has got me to an equation where I can find the common difference. Let's rewrite this again more conventionally. D is equal to Tn minus T1 over n minus 1. And now we can put in the information that we know. For Tn, we're going to use this information because we know that the seventh term is 47. So 47 minus the first term is this one here, 5, over n is 7, and that's this number here, minus 1. This is equal to 42 over 6, and that is equal to 7. So the common difference of a sequence where the first term is 5 and the seventh term is 47 is 7. Great, let's keep going. We've got one more to do. In this question, we have this arithmetic sequence: 8, 11, 14, 17, and so on. And I have a term 32. And I would like to find the position of this term. What I'm looking for is this value of n. So let's write our formula down again. Tn is equal to the first term T1 plus n minus 1 d. Now I want to isolate n. So again, we're going to have to do a little bit of algebraic manipulation. I'll start off by taking T1 to the left-hand side of the equation so that I have Tn minus T1 is equal to n minus 1 in brackets d. Now I'm going to divide both sides of the equation by d so that I can cancel these two d's, and I end up with Tn minus T1 over d is equal to n minus 1. I would like n by itself, so I'm going to take this minus 1 to the other side of the equation. I'm just going to move this up a little bit so that I get Tn minus T1 over d plus 1 is equal to n. Now we can substitute what we know into this equation here. So I'll rewrite it up here. N is equal to Tn minus T1 over d plus 1. Now, I have a value of Tn, and it's this one here in blue. Okay, I don't actually know what the value of n is, but I know that that nth term is 32, so I can write it here, 32. And I'm sorry, I'm just going to move this down a little bit. And I know that the first term is this one here, and that is 8, so I put minus 8 in here. Now, I didn't find what d was, so let's take a look. D is this term minus this term. 17 minus 14 is 3. Let's do a quick check, another one. 11 minus 8 is also 3. So d is 3, and then plus 1. Right, now we can tidy this up. 32 minus 8 is 24. 24 over 3 plus 1. 24 divided by 3 is 8 plus 1. And that gives me 9. So n is equal to 9 and this means that it is the 9th term, that is 32. Here are 4 styles of questions that make use of this formula Tn is equal to T1 plus n minus 1d, which is the formula to find any term in an arithmetic sequence. I hope this video has been helpful for you, and thank you for stopping by to watch. I'll see you next time in the next video. Bye for now.